And now we will invite our colleague from NVIDIA, who will tell you a bit about the NIMs. And what is a NIM? You'll just find out soon enough.
There's a laser. Okay, so let me first introduce myself to you. My name is Mateusz Szczesny. I work at NVIDIA on automating the delivery process of NIMs to the public, together with my team, which members happen to be our hosts today as well. I'm so pleased that today's presentation gathered so many of our community today. Let's start then. We are here today to talk a little bit about NVIDIA inference microservices. It might be a new thing to you completely. So let me divide this presentation into two different sections. In the first one, I will mainly focus to introduce NVIDIA inference service, also called NIMs, to you. I will give you a better high-level perspective of what that actually is and how you as an end user can interact with NIM. The second part, we will dive into more deep understanding what is under the hood of a NIM and why that even matters. Let me first ask you a question. Who among you is a technical person and has any experience with deployment of generative AI models? It can be like commercial one, it can be as hobbyist. Okay, quite a few. And who of you came here just to take a free pizza? No, I'm just joking. Okay. So let me briefly explain and have this high-level perspective of why we are even talking about it and why it's important. So in 2022, we witnessed a huge boom on generative AI market. We've seen that OpenAI launched the first version, not the first version, but launched the version of ChatGPT that attracted over 100 million users in just 2 months. It's enormous number. 2023 was a year of experimental phase. We've seen many big tech players came into play to prove that they can compete with each other on the market. And we are now here, 2024, and this experimental phase has already paid off. And NVIDIA took this step forward to build something that can increase the efficiency of deploying generative AI to the production, which right now, as almost every company is so hyped about generative AI, and we see all those commercials about these personal agents that can do everything for us. Why is this important nowadays? So what is actually a NIM, an NVIDIA inference microservice? Let me start with saying that all of the NIMs are available, all NIMs built by NVIDIA are available on build.nvidia.com in two ways. You can interact with them as an online endpoint, or you can actually take them with you into your local workstation, into your data center, and get the most value of them right there. But what it is, it's quite simple. It's not rocket science at all, actually. It's isolated, containerized environment that can quickly execute the inference server with generative AI model directly on your host machine. And it's so special because it comes by default with so many things that basically everyone looks for while deploying the generative AI to the production. Let me run this video. I'm doing this for the first time in my life, so let's see if that works. Yep, that works. Great. So let me show you how to have the most basic interaction with NIM that you as a NIM user can have. The video itself doesn't have any sound, so I will be a voiceover for that. Okay, so as I mentioned, to have this very basic interaction with a NIM, the very first step is to go into build.nvidia.com and log in or create an account if you don't yet have one. Then you can use this site to browse through all of the NIMs that has been already released by NVIDIA. In my case, I will take this Llama 3.1 8B instruct as an example here. Next step, once you enter this site, is to generate an API key that you need to have this interaction with a NIM from your local environment. And you can copy the code that this site comes with by default. Then I hope this will be visible to you. The next part is to create your local project. You don't need to be so technical to follow this. I'm creating a Python local virtual environment right here to have this local project on my workstation. I'm installing OpenAI Python library as it's one of the dependencies of the script that I copied from the site. Next step is to paste the code and replace this placeholder of an API key with an OS environment execution to take that from the environment variable from your host. I already set it up before recording this. And as you can see, it uses OpenAI client by default to communicate with this online endpoint of a NIM. So as you can see, it's already compliant with OpenAI API spec. You can create this communication with chat endpoint by providing the name of the model. In my case, it's Llama 3.1 8B instruct and the prompt. The next step is just to execute this script, and just in a while you can have the answer you want. So in our case, it's limerick about the wonders of GPU computing. The reason I wanted to demonstrate this is to show that it's quite simple. Even if you're not the technical person, you can just take it and try. But I can admit it. It's for some of you it might be too simple. So it started once more. Okay. For some of you, it might be too simple. So let's try another way of interacting with a NIM. Imagine that you have this NVIDIA GPU already. In contrary to what Prince said, instead of Mac, you have this powerful NVIDIA GPU already installed in your local workstation, or for some reason you have an access to a cluster that has a bunch of those GPUs. In this case, you can host a NIM directly in your data center, in your local workstation, just with 3 simple steps, and one of them is entirely optional. The first is to basically authenticate against NVIDIA containers registry with the token that you can take from build.nvidia.com. The next step is to set up a local cache. It is an optional step, but it makes sense to cache the model, as usually these are large assets. The last command is basically to have a Docker run supplied with few parameters to enable this NVIDIA runtime in Docker, to inject this API key into the runtime, to mount the cache, etc., and expose the port of the inference server back to the host. And that's all. Voila, you have the NIM working on your local workstation or in the data center. You can have this curl execution just after the Docker run command to test if that actually works. But believe me, that works out of the box. As you can already see, there is some magic going behind the hood. Like, do we pack like everything inside a container, just ship to you, and we tell that, oh, it's brilliant, it's everything? So let's have a deeper look how it behaves under the hood, under this Docker run command. On this slide, I have a short diagram that somehow depicts the life cycle of such deployment of a NIM. Once we run this Docker run command, obviously the Docker will pull the image that we specified. Then it will check if the model exists on our local storage. If there is no model, it will pull that. If there is model, it will reuse that. That's quite simple. I'm not saying anything new to you. It's like that's how usually software works. And then it will run the model itself. But it's not any model. In NIMs, NIMs by default count with this automated model pooling that is equipped with automated hardware detection that will check what kind of hardware do you use on your local workstation, and based on that, it will pull appropriate model that is optimized, especially for your hardware. Once the model is there, the NIM runtime can detect all of the components, all of the dependencies that needs to be installed in order to spin up the server. And it basically comes with all of the magic that I said about, all of the metrics, health checks, and the entire REST API that is compatible with the standards stated by OpenAI. Good. Once we have this high-level perspective of what is a NIM, and how it behaves in this local or not even local environment, let's dive into an even deeper understanding of the components of a NIM, what they are and how they behave. I'm supposed to use this actually, but this is easier. Okay. This diagram, this image basically shows all of the high-level components of a single NIM. As you can see, there is a lot going on here. We have this going from the top, we have this level of API that is compatible with OpenAI standard. I've already said that. We have Triton inference server running there, serving the model itself. On the right side, we have a bunch of names. Not everything must be essentially understandable by you. I will explain those in details on the next slide. At the end, we have this cloud-native stack that allows you to run this NIM not only in your local workstation, but it also allows you to have this NIM easily integrated with the Kubernetes cluster. And as we know that the Kubernetes is already like the leading technology to deploy models on the hardware, and it also comes by default with that. Let's take them one by one. Let's at first focus on the standard API and the Triton inference server. As an example, I will take a NIM of an LLM that we created. As you can see, it comes by default with this OpenAI compatible API that has an actual Python server running based on the FAST API framework. It by default comes with all of the endpoints, not only required for the inference, it also comes with an endpoints that serve the status of the model, that serve the metrics, all of the endpoints that you can hook on to integrate a NIM into a pre-existing observability stack or pre-existing monitoring stack. And under this high level, it's not already high level, but this high level server layer, we have this LLM executor that is smart enough to detect what kind of hardware do you use, and based on your hardware to detect which model, right now I'm saying model, but we will cover the optimization on one of the next slides. Which model should be executed on your GPU to serve the best results, to have the lowest latency or the highest throughput, to be the most efficient one? And as I already mentioned, choose the best model and the optimization. Let's have a look at this part of NVIDIA TensorRT, TensorRT LLM, optimized model, and all of those magic beasts that you see on the right side. That is the core of why NIM is actually efficient. NVIDIA put some effort into optimizing those models on GPUs to serve a particular reason. If we want to have a NIM that we know that serves the best inference server on our own hardware, the NIM is a way to go. And why is that? And basically, let me ask you a question. How many of you are already familiar with TensorRT or TensorRT LLM? Okay, not so many. That's actually good. That proves this slide can be valuable. So what is a TensorRT and TensorRT LLM? Let's first start with TensorRT. It's basically a high-performance deep learning Python SDK. That's the definition from the documentation. But what that really is, what value can I get from using TensorRT? The reason is that I can use TRT, which is like an abbreviation of TensorRT, to convert a model, an AI model, into a more optimized version using multiple techniques that will somehow alter the kernel, that will alter the layers of the model to improve its performance in multiple dimensions. So it comes by default with features such as graph optimization, layer fusion, precision calibration, etc. You can read about it in the documentation. And I'm not an expert when it comes to this machine learning mystery. I'm an expert in automation. But the reason I'm showing this is that the TensorRT powers the inference server of a NIM. And based on my example that I took for this presentation, we use TensorRT LLM, which is another library that is built on top of TensorRT and has been especially designed to serve its purpose for the large language models. By default, it comes with an additional mechanism to optimize typically large language models, such as attention mechanisms such as KB cache and other mechanisms that lets TensorRT to optimize the layers, the kernel of your model. It also by default comes with multi-GPU support, etc., etc. And it's quite interesting because if it comes with multi-GPU support, you might have a question if NIM supports multi-GPU at all. There isn't. The answer is true. But let's stick with TensorRT right now. And let me show you this slide. It somehow depicts that TensorRT, apart from this mathematic mystery that allows you to optimize your model, is actually a quite simple tool with quite straightforward interface. You can actually use TensorRT yourself. It's not something that is proprietary and unavailable for you. You can take that. We can also have those sources that I put on this presentation on YouTube in the description. I believe that's I'm looking at hosted. Is that possible to have those sources on YouTube? Those links? Good. You can check those because like this is on only a high level perspective. There is more going on when you take a deep dive into the details. So what is TensorRT? We can like shrink this entire thing into 3 different steps when it comes to usage. The first is to convert a pre-trained model into a checkpoint in a format supported by TensorRT. It by default comes with a handy script that allows you to actually do that. The next part is the TRT LLM build binary that fit with a proper set of parameters in terms of the plugins that you want to use, whether you want to use LoRa or not, about the information of the parallelism during this model export. All of that allows you to alter the core of the model into a more optimized version of that. The result is actually a model, but in NVIDIA we call that a TRT engine. That is a real core of the NIM of the model running inside of a NIM. Not the last thing, but as I mentioned, NIM also comes, not itself, but it also comes with a bunch of tools that allows you to integrate it into your pre-existing Kubernetes cluster or new Kubernetes cluster or your infrastructure in general. So let's see what that is. We do not only ship the Docker image itself that is pre-built, benchmarked, optimized, etc. We also ship NIM as a current chart to make Kubernetes deployment straightforward to the user. Such NIM comes by default with model cache support. It by default comes with multi-node support, thanks to this LWS or MPI job, depending on which NIM do you use. It's currently, like, it's obviously, some of you might not even heard about it, but it's cutting edge technology. So like some of these are not available for all of the models, some of these are available for all of the LLMs, etc. The value is in simplicity. We want to ship those NIMs in the most straightforward way to the users to enable the enable the deployments to be highly efficient and to do not spend time on like fighting with Kubernetes on how to deploy that. And there is this last part I want to focus on. It's called on this diagram a cloud native stack. You might be already familiar with what Kubernetes operator is, but recently we started developing our own Kubernetes operator called NVIDIA NIM operator. It's currently available only in this NVIDIA developer program, which link is in the presentation, and we can put that on YouTube as well. We want to have even one more step further and make Kubernetes deployments for NIMs even easier than just using a current chart, which, to be honest, it's already quite easy. We want to have this, eventually this NVIDIA operator that by default comes with custom resource definitions that you can use to define a NIM in your existing cluster in this like native fashion of defining Kubernetes resources. That put together with NVIDIA GPU operator to enable the compute power of the nodes in your cluster ends up with NIM deployed to a quite complex Kubernetes cluster in just few YAML files. Obviously, we also, I haven't mentioned that just quickly, but those server also comes with those. Maybe there's a message to me to like move forward. Yeah. It comes already with the metrics compatible with most of the with the most popular observability stacks on the Kubernetes. So you can take directly Prometheus metrics from the NIM itself. That's why it enables this Kubernetes deployments even more. So like, I believe this like a really brief introduction of what NIM really is and how you can interact with that, how you can use its power on your compute, and how you can try this on your own. I believe that this solution will expand in the future, providing even more models. You can browse all of them on buildnvidia.com and check. Like every model comes with a model card with the benchmarks, so you can actually check the numbers measured before releasing such NIM to check how powerful it is to use this NIM. I strongly believe that you will be interested in checking more from sources that I put there. And I hope that you enjoyed the presentation. Thanks for having me. And here is the place for questions.
So, thank you, Mateusz, for this great presentation. Now it's question time. If you have any questions.
Hey, it is great actually, because we were researching this some time ago, a couple months ago, for the customer, and yeah, the easiness of deployment, that really works great. But when it comes to the commercial license, we started, checking this out, and I think currently, maybe you can correct me if that changed. It's around 4,500 euros per year per GPU to self-host models. If you want to do this commercially, is this still the thing, or did it change in between?
It's a great question from you. I'm not an expert of those like price tables, etc. So I don't know, to be honest. I don't know if that changed and if it's supposed to change in the future, if it will like be reduced or grown. So the best way is to check that out. And I'm not quite sure what are those rules of this developers program. But it's like the best, like, I don't know, but the best way is to monitor what is going on. But may I have a question to you? Was like it was like a general pricing, or is it per NIM kind of pricing for you?
Because developer program is free for research, implementation and so on. But then if you want to move something to commercial deployments, then you need to apply to NVIDIA Enterprise program. And I think their pricing is basically, if you want to deploy, I don't know, like one or multiple NIM models to one GPU, this license for one GPU costs 4,500 euro per year.
Got it. Okay.
Great presentation, man. I really liked it. I saw the part where you talked about multi-node. Could you elaborate on what you meant by the multi-node part?
Which especially?
There was a part you talked about multi-node. It's new, and you guys also are gonna support this.
Yeah, so we've already shipped. I believe it was for LLM. It was most probably Llama 3.1, 8, and 70B. But like, don't quote me on that. But please just check. So we shipped that as a Helm chart that you can apply to your cluster, and it uses under the hood from the structure trace. It uses LWS, which is a leader worker set of Kubernetes. Is a custom CRD that is shipped from this community of people working on the Kubernetes, and under it creates a stateful set, which is a leader stateful set, and a bunch of workers and another stateful set. And the way they communicate with each other is because they use the MPI as a protocol message through the network that allows those computations commands to spread across different nodes. And the leader stateful set and the worker stateful set are connected with each other through the local network in the cluster, and sends the computation commands through the network to other hosts.
You can take parallel inference where you have parts of your model distributed, layers of your model distributed across different.
That's correct, across different nodes.
MLX uses MPI as well to do something like that with the distributed side. Is one of the things that I've been looking into. That's pretty cool.
Thanks for the question.
Hi, so you mentioned that at some point it will recommend a model for you or will bring a model for you if you deploy it in your own machine. But I'm still allowed to use another model or switch for something else, or I have to stick to what it recommended for me.
So this needs to be checked. There is an option to select a particular model that you want to serve on your machine, especially like imagine there are 3 engines, like 3 of them are optimized for H100 GPU, 3 of them are optimized on A100 GPU, and you really want to have this H100 GPU that is optimized for the lowest latency. So there is an option to do that. On the spot, I will not tell you how to do that, but you can check the documentation. I believe there is an option to actually check to actually change which model will be served, but it will automatically detect which GPU you have on your host, and it will select the most balanced model that will serve like this in between.
Show me that model that is already pre-selected for me.
What do you mean by that?
It will check first my let's say
like local cache, yeah, like this directory on the host, right?
Like some model for me, right? Will I know that model already?
Okay, so it will, during the first execution, it will check the cache that is mounted or not mounted, like just this local directory for the model. If the model is present and the checksum is correct, so like we know that this engine on your local machine is the one that we are looking for, the runtime will pick that up and serve it for you. So like with every other execution on the same machine, it will have this pre-cached model.
Thank you.
Thank you very much.
Yeah, maybe this is like too stupid question, but like, how does this compare to, for example, me going, since your offer is going to fade, if I were to commercialize correct, how does it compare for me, like going to the run pod and then like a serverless Docker container with a GPU model there? Why should I pick NVIDIA's solution rather than something much cheaper and for me it's like more flexible? Because for me this seems like as an overcomplication, and I wonder why does it exist? Probably not educated enough, but you're probably not there.
Okay, I think that depends on your intention. Like if you really want to focus on the model, like what is inside, like why is that fast, etc., is probably not the right way. The main purpose of NIM is to, as title says, to speed up the deployment, to make the experience of deploying generative AI to the cluster as easy as possible. That's why there are all dependencies, those mechanisms of hardware detection, those optimizations going on to make this as simpler as possible. So it's focused on the simplicity of deploying, not model essentially. So if you really want to deploy as soon as possible and based on the experience of a colleague sitting next to you, it's quite easy to deploy this. It's definitely low effort to have this in production. I don't know the other solution that you mentioned, so I'm not able. Not really.
Just like a cheap GPU service. So you have like services where you can rent GPUs for like hours, or like they just bill you by hour. So something like this, they have basically a solution where you can upload your Docker and run it on a cluster with the GPUs, and it just scales with the amount of requests coming in. Basically what you're doing, but I wonder, why do I need Kubernetes? I guess every time I hear Kubernetes, I'm like, no.
Oh, okay, got it. I will stick to my answer. It depends on your intention. If you want to choose this and the like simple mathematical calculations says that it will pay off, like take it. If it's like too expensive for your use case, or you just want to play as a hobbyist with this entity, with this developer's program, it's maybe a way to go. So like it depends on use case, and if it's like for this particular use case an overkill in terms of pricing, or probably not the effort, because that's we aim to reduce, that's like choose the right one.
Thank you.
Hi, I wanted to ask if there will be an open framework for new images, because, for example, we can imagine that already to H100, that's quite a lot of in terms of money and VRAM, and I could quantize quite large model to run onto H100s. But would it be possible also to do similar operation for NIMs?
Okay, so let me rephrase to make sure that I understand it correctly. So you want to ship your own model with the software stack that comes with a NIM, right?
To this feature that NIM actually selects, optimizes.
Got it. According to my knowledge, there is no option for that, but like this is a cutting edge. Like it changes daily. So monitor what is going on, and I have no such information that will be possible. So unfortunately, the answer is that, to my knowledge, there is no such option right now.
Thank you. But I believe everything in LLMs changes so fast that maybe.
Hi, it's me again. I have two questions. So the first one is like quantization. How are you guys handling that? What are the different precisions that you are using in NIMs or you recommend in NIMs? And the second question is kind of an extension of what Robert asked, which was, what's stopping me from using VLLM? I noticed that VLLM is kind of I think a part of the stack. What's stopping me from just deploying a VLLM instance using Docker or not, but like you start using that to serve a customer instead of like going through the process and actually adhering to NIM standards?
Okay, so the first question of what kind of precisions for quantization. Okay, so according to what kind of precisions, I believe that quantization happens at FP8. In terms of how does it happen, like I have no real answer. As
not in that sense, not in the sense of like how the quantization is kind of works, but kind of how do you guys do it? Because when you say FP8, I know if I remember correctly, FP8 is only for like H100s. If I have A100s, it won't work the same way. If I remember correctly.
You do.
The types of architecture and NVIDIA GPUs that are not H100 that don't support FP8. Do you guys offer other types of like quantizations like 4-bit and so
Nope.
on that
Nope. No. And the other question that you asked?
What if I'm using VLLM instead?
Like nothing stops you, basically. That's the answer. You can similarly, based on your use case, select the appropriate. The VLLM runtime is basically like a default option. If you know, like there is no optimization that directly fits your hardware, that like VLLM is the default way to go.
Okay, so I could just skip it and use VLLM.
In that case, it might be true, but like, what's the point of having? If you have this GPU like already A100, like you don't want that. You want this optimized one. It will be faster.
Yes. Do you have any case studies that I can like go through just to see the differences between NIM and other offerings?
I recommend to check the build.nvidia.com, as there is a page dedicated to like announcements or news or some kind of that. And the documentation. It is, as I change, it's changing rapidly. So I remember there are some cases and some partners or companies that have already tried this mentioned, but I strongly recommend to check this on your own.
Thank you.
Thank you.
Do we have some more questions?
So I have, first of all, thanks for the great presentation. I have two questions. One is a little bit more open-ended and maybe a little bit philosophical, so I will ask it as a second. And the first one is related to actually the first question today about licensing. So the first question was about pricing, and my question is actually about licensing. So is it, like I saw in the presentation that some components are open source, but I think not all stack is open source, yes? And are there any plans to make it open source or make it some kind of standard or something like that?
So one of those slides, I haven't mentioned that, but one of those slides said that there are different NIMs available on build.nvidia.com. There are the part that was essentially built by NVIDIA, our proprietary models that are currently, like, don't quote me on that as well, but they are currently available only as online endpoint method of interaction, not as a downloadable one. There are models that comes from partners, and the license, to my knowledge, the license depends on the model in that case. And there are also open source models that you can take directly from Hugging Face. And the optimized version of them is under NVIDIA's license, to my knowledge. And about the plans,
To clarify this question, of course, the models may have different licenses, and it's like a very important part. But I was more thinking about the orchestration part. So, like Helm-chart, the operators that you mentioned, that you need to go to a developer program to be able to access them. So, like this tooling that it's used to basically deploy Kubernetes.
So again, to my knowledge, these are available under this developer's program license only right now to researchers, not an open source community at this moment.
Okay, thank you. And the second question is like open-ended. So what do you think about, because for inference, you trying to be compatible with OpenAI API. And I believe it's extremely convenient for developers. But do you think it's a good idea long term? Like some of us remember the case when Android was copying Java API from Oracle. There's the famous court case. So do you think is it good for like the development of AI tools to rely on OpenAI standard that is actually not the standard, something that they can come up?
Like as you said, it's a philosophical one. Like my personal thought on this is, I'm a pragmatic person. If something works and I can use that, and I have a like deep belief that it will work in the future, I will pursue for that. So I think it's like, from my perspective, it's not a matter of who invented that, rather how it works, or can we rely on that thing?
Quick question actually about this. How can we, if you think we can rely on that? Like, for example, if you catch up with the changes in the API, because when OpenAI is doing libraries, you have to update your inference servers according to the changes. See this as some kind of problem.
Yeah, to some extent, definitely. However, like, we see that even the framework that Prince presented comes with this OpenAI API compliance layer. So, like, there is this movement on market or in community in general to make APIs that are compatible within, and to some extent, it speeds up the development of the entire. That did all of the models, right?
I have a comment. So perhaps, in terms of like enterprise thinking, I think this is like a great decision on the NVIDIA's part, because if those big enterprises now rely on OpenAI or I don't know OpenAI, if you keep the API compatible, they have let's say more smooth journey to moving from OpenAI, proprietary OpenAI, to eventually something open source, potentially open source. Yeah.
Questions? Or questions? So I can see the more question. Thank you, Mateusz.
Once again, thank you for having me.